All right, today we're kind of switching gears. We're going to be working still with bases and powers, but today our powers will all be rational exponents. So our powers will be rational expressions, meaning fractional. Remember, rational numbers are anything that can be written as a fraction. So if you have a rational exponent, it means you have something like a base, which I'm going to use as n, raised to a fraction. The top part of the fraction, the numerator, is the power, and the denominator is the root. So if you have a number with a rational exponent, you can rewrite it in radical form where your root, sits on the tail of that radical symbol, and then we have some number raised to a power. Now you could also rewrite this as we have our root, and then we have our number. We could also say that the whole thing is raised to the power. Either way is fine. So a couple of standard rational exponents are n to the 1/2. If you have n to the 1/2, a 1/2 power just means a square root, or you don't need that. 2, you know that a square root is just an implied 2 sitting on the tail of that root. Another, kind of basic or well-known rational exponent would be maybe let's say 2 to the 3rd. So how would you rewrite this? Well, the root goes on the tail of the radical, and you could write it as n squared like this, or you could write the 3rd root of n and then that quantity squared. So what we need to do today and tomorrow is get really good at converting between the two forms. So let's take some examples of converting between forms. And we're going to do quite a few here in not much time. So here's example 1. Let's convert the 4th root of y to the 7th to a rational exponent. So our base is y. What's our exponent? Power over the root. Roots go under the ground, like on a flower or something. So the root of your radical will also go under the fraction bar. So that's number 1. Let's try another example. Number 2, what would be the 8th root of r written as a rational exponent? Well, you would rewrite this as r to the, what's r's power? 1 over the root of 8. Pretty easy, right? How about another example? If I gave you h to the 5/2, how would you rewrite that in radical form? So can you convert the other way? Well, h is going to be underneath some sort of a radical. What's the root? 2. What's the power? 5. So the second root of h to the 5th. Now, do you absolutely have to put that 2? No. When you're talking about square roots, the 2 does not need to be there. But I like to put it there just, we're learning, we're practicing. Let's do another one. This time, how about g to the 3/7? Can you rewrite that in radical form? Pause the video and do it. Did you come up with the 7th root of g to the 3rd? I bet you did. You're smart like that. All right, then let's put a little bit more meat to these problems, and let's do some basic simplifying. Let us simplify. All right, I've got 32 to the 1/5 power. I want to simplify 32 to the 1/5 power. Well, I'm going to rewrite this, first of all, in radical form. The 5th root of 32 to the 1st. Now 32 I know to be 2 to the 5th power. Woohoo! 5th root, 5th power, cancel each other out, and I'm down to 2. That's it. Another one. Let's try this next one. We're going to take a look at 5 to the 1/2 times 45 to the 1/2 power. Okay, so what does the 1/2 power mean? It means a square root. So I'm going to think of this as the square root of 5 times the square root of 45. Remember from a previous section that as long as you have the same root, you can multiply the innies. Now, 5 times 45 is, I don't know, 5 times 9 times 5. Ooh, 45, 9 times 5. I like that because then I could rewrite this as, even better, 25 times 9. The square root of 25 is going to give me a 5, and the square root of 9 is 3. So that is 15. That's a beaut if I've ever seen one. Beautiful. 15. Okay, so who would have known that 5 to the 1/2 power times 45 to the 1/2 power works out to be something as familiar as the good old number 15. So that's that. Now let's take one more shot at simplifying. I'm going to give you -3 to the 1/3 power times -3 to the 1/3 power times -3 to the 1/3 power. And before I go any further, I'm going to think to myself, time out. Can I take a third root of a negative number? Yes, yes, I can, because I know that as long as the root is odd, you can take an odd root of a negative number. Okay, so let's see. I have at this point the third root of -3 times the third root of -3 times the third root of -3. Do you see how that's written? Now this would be the third root of -27, -3 times -3 times -3 times -3. And that's like the third root of -1 times 27. We're going to call that -1 times 3, which is -3. Ta-da! That's it. Okay, now I want to show you one last, maybe quicker way of doing that. How do you feel about -3 to the 3/3 power? Now, 1/3 plus 1/3 plus 1/3 is 3/3. That gives me -3 to the first power, which is just -3. So that's an alternative way of doing that problem. So if you have the same base with an exponent, you are going to add those exponents together. 1/3 plus 1/3 plus 1/3 is 3/3, which is just another name for 1. Okay, so I'm going to stop there, converting between radical and rational form when you have rational exponents.